This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic. Alright, this is our third video on graphing the cosecant function. And we're going to do this problem, y equals the cosecant of 2x over 3. And remember, cosecant's the reciprocal of sine, so that's the same thing as 1 over the sine of 2x3. So this is the method we're going to use. We're going to graph y equals the sine of 2x over 3, draw our asymptotes, and then notice the max and min points for the sine and cosine graphs, not the cosine graphs, and the cosecant graphs. Switch. Now this is just one method. You of course could just plot a bunch of ordered pairs like an F to get a real good picture. But it's easier to get your vertical asymptotes this way and your key points. Now something new about this compared to the graphs we did in part 1 and 2 is we have a different period this time. So that's the first thing we're going to have to do. Alright, so to graph y equals the sine of 2x over 3, we need to know the period. And note that the coefficient of x in the parentheses is 2/3. So remember the period is 2 pi over that. So it's really 2 pi divided by the 2/3, which is the same thing as 2 pi times 3/2. So that our period will be 3 pi. So you will have the same period for the cosecant, so I'm going to write this up here. The period will be 3 pi. Now, when you graph the sine function, remember if the period is 3 pi, that means it goes in between 0 and 3 pi. So before going on, let's say we've got our sine function here. And how's this going to look? I know there's going to be these key points until I get to 3 pi. And it's easier to get a common denominator for these places on the x-axis. So if you start at 0, because at the sine function we usually start at 0, it's 1/4 of the way to 3 pi. So if I start at 0, my first key point we know is going to be here. This is for the sine function. Remember it goes like this. Just so you know how you're going to label these. Then you're going to take 1/4 of 3 pi. So this next point is 1/4 of 3 pi. So 1/4 of 3 pi would be 3 pi over 4. So keep in mind, this is 3 pi over 4, right? And then we add, so from here to here is 3 pi over 4. I'm adding 3 pi over 4 again. That is 6 pi over 4. Adding 3 pi over 4 again, that's 9 pi over 4. The next one would be 12 pi over 4. And that is the same thing as 3 pi. So if you were to label these x-coordinates or put it in a graph, those are the actual values on the x-axis. It gets kind of messy there, and yes, you could certainly reduce this to 3 pi over 2, this middle one, etc. So for the moment, I'm not going to keep these on here because of the messiness of it, but if you were asked to write those ordered pairs, again, that's how you would do it. So I'm just going to write down what the ordered pairs ended up being over here. The key x-coordinates that we got were 3 pi over 4, 6 pi over 4, 9 pi over 4, and 12 pi over 4, which of course is where the period should end. Okay, now, so we're going to graph y equals the sine of 2x over 3. That was just a little review of the period and how we're going to do that. So let's see, I need some places on the y-axis. So let's call this 2 and -2. And over here, 1, 2, 3, 4. Let's say there's -3 pi. All right, so if we were going to graph y equals the sine of 2x over 3, we would have it going up first, and then we go down over here. And we have this graph right here. We could also go to the left, etc. And now we simply take the find the asymptotes next. All right, so wherever it crosses the x-axis, we know those are asymptotes. I'm going to put it in red so it's easier to see. So the asymptote, here's another place where it goes through the x-axis. There's an asymptote. There's an asymptote. Okay. And then what do? The maximum points of the sine end up being the minimum points, and we just use these asymptotes as guides. And there's our graph, and we've labeled our x and y axis correctly. Just getting an idea. So there's the graph. So I've got the period. Let's go ahead and also state what the equations of the vertical asymptotes are and what the range is. So let's see, I'm going to put this in a smaller screen so we can get everything to fit in. All right, so here's our function, y equals the cosecant of 2x over 3. And here is our graph. And we had already determined the period is 3 pi. We have one full cycle between 0 and 3 pi. And so what about the range? What are the values the y-coordinates take on? Well, remember it goes down forever, so it goes in between negative infinity all the way up to 1. And usually that has to do with the coefficient of the cosecant, right? Like if it was 2, it would be 2. If it was 3, it would be 3, etc. So we've got negative infinity to 1, union 1 all the way to infinity. Okay. VA, that stands for the equations of the vertical asymptotes. Okay, so it's a little bit trickier. And remember, this was halfway between 0 and 3 pi. And when we'd written all those down, I wrote 6 pi, I think, over 4. But that's the same thing as 3 pi over 2. So basically, every 3 pi over 2, I'm going to get another vertical asymptote. That's how you can figure that out. All right, so I start at 0, go 3 pi over 2, I get a vertical asymptote, go 3 pi over 2 again, spaces, I get another vertical asymptote. So these are vertical lines, and vertical lines are in the form x equals. So I have to write this number times k. So you could just write 3 pi k over 2. You're showing you're multiplying it by k, where k is an integer. I'm not writing down the domain, but remember, if you wrote down the domain, it would be everything except, all real numbers except 3 pi k over 2, where k is an integer. Often we just write the vertical asymptotes down. It's easier because then it's clear that the domain is going to be everything except that. This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic.